Today, we're diving into two of the most commonly used voltage regulators, the LM7805 and the LM7812. If you've ever built a power supply circuit, chances are you've encountered these integrated circuits, or ICs. But what do they actually do, and how can we use them effectively? Let's start with a brief overview of voltage regulators. A voltage regulator is a device that maintains a constant output voltage regardless of changes in input voltage or load conditions. Linear voltage regulators, like the LM78XX series, are particularly popular because they provide a simple and effective way to achieve stable voltage outputs. The key difference between fixed regulators like the LM7805 and LM7812 and variable regulators like the LM317 is that fixed regulators output a specific voltage, while variable regulators can be adjusted to provide a range of output voltages. Now, let's compare the LM7805 and the LM7812. The LM7805 provides a steady 5V output, making it a go-to choice for powering Arduino boards, sensors, and microcontrollers. On the other hand, the LM7812 outputs 12V, which is ideal for driving motors, relays, and LED strips. Both of these regulators are designed to handle a decent amount of current, but they do have their limitations, so it's essential to check the datasheets for specifics. To visualize how these ICs work, let's look at some circuit diagrams. The LM7805 typically requires a couple of input capacitors for stability, and it's connected to the load directly. The LM7812 follows a similar setup, but with a different output configuration. Understanding these diagrams is crucial for ensuring your circuits function correctly. Now, let's move on to a practical demonstration. Using Proteus simulation software, we can simulate both voltage regulators in action. You'll see how the input voltage is transformed into a stable output voltage. For a real-world example, I'll show you a breadboard setup with the LM7805 powering an Arduino. It's straightforward to set up, and you'll notice how easily it maintains the 5V output. If you want to convert an LM7805 setup to an LM7812, it's just a matter of swapping out the IC and adjusting the input voltage accordingly. However, there are some common mistakes to avoid. One of the most critical aspects is the importance of heat sinks. Both regulators can get hot, especially under load, so adding a heat sink is essential to prevent thermal shutdown. Additionally, correct capacitor placement is vital for stability. Make sure to place the input and output capacitors as close to the IC as possible to minimize noise and improve performance. Lastly, while the LM78XX series is widely used, there are alternatives worth considering, such as buck converters. These can be more efficient, especially in battery-powered applications, as they reduce wasted energy. So that's how the LM7805 and LM7812 work. Which one do you use most in your projects? Let me know in the comments.